Both headlights stopped working on my Ninja 300. Both, the high beam and the low beam. And I checked the fuses, as you can see in this location here underneath the seat. And I came across a wonderful autopsy of relays, which is this box that you see here under the seat, and these three plugs are missing from. A gentleman named Clive, here he is doing an autopsy on this relay box that came out from under the seat of the Ninja, and was able to locate, like, he did a complete breakdown of this thing. And the problem was actually exactly what the problem I'm having with mine. And thankfully, because Clive did that total teardown of this piece, and he had some great tools to do it with, and skills and tools that are a little beyond my capability. But the information that Clive gave me out of this allowed me to dare to do what I was going to do, which didn't quite go as far as he went. And this little diagram on the back really gave me a lot of information and confidence about which relay I needed to work on and what the wiring is set up for. And so, the first section of this video is about me attaching a car headlight relay to the back of this board without having to tear it down as far as it was done in the autopsy. And when I ran into some trouble, it was also containing, the video also contains the continuity tests and the results. So, follow along. Alright, carrying on from where that fine gentleman showed me how to actually locate the relay, I set up the two heavier gauge wires. Oh, sorry. First I got a 4-wire 12-volt car headlight relay. Basically, you can get 5 of them for $20 on Amazon, Canadian. And the two heavier wires, I connected to these two items, which are relay 1. And the two lighter gauge wires is what actually triggers the relay. So this delivers the power. It's the switch that gets closed between these two wires, which will deliver the power out to the headlight. And this is coming from the items that activate the headlight. Now, the relay that's on the other side of this board is burnt out and garbage. So basically, by the suggestion of the fine gentleman who did the autopsy on this board, thank goodness he held it in a very particular way so I could see the wiring diagram on the back side of this, and I used a tester to figure out which pins that each of these things goes out to. And I was able to wire a 4-wire relay from the car there, and you can see it works because when I touch pin 11, okay, so why am I saying pin 11? So we're talking about this relay, A, which is relay number 1. And I've hooked up power to number 2. Number 2 and 3 pin is the part that triggers the relay. No, sorry, 2 and 11 triggers the relay. You see the wire going there? There's 2 through the curly coil. That's the actual trigger mechanism. It goes up there and comes out on pin number 11. So the pin number 11 is the only one I don't have hooked up right now. So I have pins number 3 and 1. Or is it 3 and 2? It actually doesn't matter with the different things we have going on there. But 3 and 1 I have hooked up to the actual headlight on the motorcycle here. So that headlight is going to turn on. Here's where I've hooked it up, 3 and 1. They roll back into here, 3 and 1 pins. And you can see 3 and 1 are those pins there. And therefore it matches up to this middle section. And pin number I apologize, I've actually forgotten how I what I've got. Oh yes, the other pin is for the pin number 3 and 1 are load. 11 and 2 are for triggering it, and that's why 1 and 2 both have a pin in there. So you can see 1 and 2 are wires coming in. 1 and 2 are the ones that I have plugged in here. 1 and 2 is power in. Oh, by the way, the gentleman who did the autopsy would have told you that those diodes matter. So whenever you see those diodes, the power has to come in from there. It can't be the negative, it's got to be the positive coming in there. So positive power is coming into those two, and the load going out to the headlight is there. Oh, is one of these, right? It's connecting the headlight between these two. And the last thing I have to connect is to make the relay close. So pin number 11 is what makes the relay close. So let's go here. Pin number 11 is pin number 11 on the diagram is the second one over from the bottom. So it makes a lot of funny sound, but you can see, I hold that there, my voltage generator, and you can see the headlight turned on. The funny sounds was because the relay was turning on and off and on and off because I wasn't making a good connection. Now I've made a good connection. Well, folks, I wish wholeheartedly that I was really just displaying a Ninja beaming its headlights across my garage and my happiness dance and all those kinds of things, but I plugged it into the Ninja and it didn't work, despite working on the bench just fine. So I've now I've pulled it back out of the Ninja, brought it back here, and I feel like there's something I'm missing from this wiring diagram. So basically I'm switching tools. Here's the relay that I've patched on. I'm going to use the circuit diagram, and I'm going to be using this tester in continuity mode. And I want to make sure that the pins, that I understand correctly which pins are connected to which one of these wires that I soldered in. So the remainder of this video is my process where I went through that. And at the end, I summarize my results and talk about the wiring diagram and things like that and what I need to conclude from this. Thanks, folks. Carry on, Tom. Okay, what I've decided to do is to identify the immediate location of the pins that attach to each one of these 5 locations. Now, only 4 of them I've actually soldered to. This 5th one I saw in the autopsy video. Came out as well when they pulled the chip from the other side of this board. So all I've done is soldered in another relay. And because when I put this back on the motorcycle, I don't get headlights again. I'm thinking there's something to do with this 1 and 2 input. So I want to identify what on the board, oh, that's my continuity tester beeping. What on the board corresponds with this pin and either this pin or maybe one of these, this pin and this number 11 pin. So they're all numbered here, and because they're numbered, I can use this diagram to find out where they are on the face of things. However, what I can't determine is which pins does this one lead to? Which pins does this one lead to? Which pins does this one lead to? And that one. Okay, that's my objective in this next step. Okay, so first the blue solder point. So the blue solder point, I have this hooked up to pin number 11. We show it on the diagram there. See pin number 11? And here we are, pin number 11. So 11, I think, according to this diagram, pin number 11 is out over here. So pin number 11 is one of the two pins that I need to connect in order to make this relay close. Casper, get out of there. And I need to figure out which one that is. So I've got my continuity setting on my on my tester. We'll just call it the tester for now. And my tester is only set up with 2 plugs, so you don't. I know sometimes with continuity you have to start moving these around between different plugs. This one is not set up that way. So I've got it set to continuity. It says 0L, which means nothing is happening. There's no electrical through connection. So I'm going to touch it to the blue wire, and it still says 0L. So 11 to 0 to the blue wire is 0L. 11 to the red wire, nothing. So it's not connected to the red wire. To the white wire, come on now. To the white wire is a full 0 setting. So that usually what this thing does when on continuity is it gives you a number when it says it's got some kind of resistance. And this has 0 resistance, so that's a perfectly through to number 11. And now to the black wire. Now this one's kind of interesting. The black wire is showing up as a 38. So what would this mean to me? So let me first write this down. So pin 11, blue is, oh, don't even bother. White equals 100%. And black, right, the black point equals, what was that? Some certain amount of, I think that's a measurement of ohms. Let me see again. 0.039 resistance. So what do I conclude from that? I think that pin 11, I think this reflects what's going on in the diagram. Pin 11 comes down here and across and through this and out that way. So pin 11 is connected to this point, is the first point that I pressed, the white wire. So this is the white wire. Oops. This is the white wire. And this point is the black wire. Now, whether it's this point or is it one of those 2 points? No. All I've done is measured. Oh, that's why I was thinking. This little curly thing is making up the resistance. So this is the trip thing that physically closes this gate. So I'm seeing the black with a little bit of resistance because it has to come through there. But there's still an electrical circuit. It's just meeting some resistance to trigger that gate. And white has 0 resistance, so that's why I know it's on this side. So hopefully I've got that right conclusion. And let me move to another pin. So I've now moved to the other side of the resistor on this diagram, and I'm going after pin number 1. So I want to see if pin number 1 is in any way connected to this point. All right, I know pin 1 is going all the way around to one of the loads, which is fine. But here I want to check if it's pin 1 is connected in any way to there. And it should be, I just don't know how. Let's see. Okay, so what I scope out that section to be, so first of all, I've got this connected in pin 1. And I'm assuming from the wire diagram, okay, stop everything. I had to throw out a whole bunch of video. All these times I thought I was plugging into pin 1. I think I was plugging into pin number 4. Here's pin 1 on the diagram. You can see now I've actually got it plugged into pin 1 properly. So I'm going to basically redo my tests to record exactly what the continuity is for each wire from pin 1. Pin 11 was okay. Pin 1 I had to redo. So, pin 1, black, 0. No wire, 0. White, 0. Red, full connection, no resistance. Blue, nothing. So basically pin 1 has full connection to the red wire. And interestingly enough, according to this diagram, you can see here, pin 1 should have a full connection, uninterrupted, no resistance to the red wire. But why didn't it register anything on the black? That is a weird occurrence. Now I'm going to try and figure that out. First, I'm going to try reversing the red and black, so the positive and the negative in my tester. When continuity testing, apparently your tester sends a very low voltage through the wire, enough to detect if something is there, and if it isn't there, how much resistance. Or if it isn't faintly there, how much resistance it's experiencing. So I'm going to go 1 to the black again, except I'm going to reverse the polarity and see what comes up. Okay, this time you can see I have the black wire going into pin number 1, which is the negative, and I know that's counterintuitive to what the diagram says. The diagram says that that's where should be your positive coming through there, and the diodes only flow it through one way, but I don't know how else to do this, so I'm going to check if black gives something when it's switched around. No, it doesn't. To the red, of course, full connection. There's no diode there, by the way. To the white, nothing. And blue, nothing. And this no wire connection, nothing as well. All right, I'll write down these results. Sorry, actually, I should record my conclusion from that. It wasn't a case of me misunderstanding the diodes. This electricity was flowing in the right direction for those diodes, so I'm going to go back to sticking to red as being the power source, or the positive, that I expected to flow from the pin number 1 down through, and I should be able to measure it at the black location, and I cannot for some reason. So we're going to try and figure that out. I'm going to go from 2 to the black location again. Okay, I moved my red connector from pin 1 over 1 space to pin 2, and you can see on the diagram, there's pin 1, I moved it to pin 2. And let's see what happens. So, on the red, come on now, nothing. On the black, nothing. On the white, nothing. On the blue, nothing. Could it be, it's still a reasonable conclusion then, that a diode is actually preventing me from doing a continuity test, but I will again reverse the black and the red just to make sure that's not the cause. Okay, here we're going to do the continuity test, and we're going to go 2 to the black. That's what I'm really interested in there, to see if the diode is really messing is the problem. So black, and this time I have black and red reversed, right? And what you were able to detect, regardless of what our dog was saying, there's no connection there between that and that. That's with the opposite of what we would expect in the flow. So again, I'll go back to putting the red in the pins, because I want to assume that positive is the way to flow correctly through the diodes. But I think what I have to conclude is when those diodes exist, you can't do a continuity test. You can put power through them, but there's not enough power to go through the diode and detect any kind of connection. Okay, pin 3 testing. As you can see, pin 3, we should expect to have 100% connectivity to blue and no connectivity to anything else. Pin number 3 is still in this middle block, and it's in that bottom or top right corner if you look at it from this, top left corner if you look at it from this section. Now, let's do some continuity testing on blue, because that's where we expect to get a value. And blue showing full connectivity. That was expected. Red, we expect nothing, and we get nothing. Black, we expect nothing, and we get nothing. White, we expect nothing, we get nothing, and this default position. Oh, now, this no wire position is a full contact, and that can be explained. See that little point right above the A that I kind of drew in here? That represents the connection that it sits against when it's open. So this goes nowhere, does nothing. But when it's open, there will be a way to generate electricity through here. So it's showing that this in fact, that extra point, that extra wireless unsoldered piece is in fact just what the gate rests against when it's open. So let me tell you a little bit what we're looking at here. Basically, this is the conclusions of what I've done through continuity testing on this broken relay. Now you remember I'm dealing with relay number 1. There's a burnt out relay on the other side, identical to the autopsy results, and I've soldered a new relay on the other side of this. On the left side of this picture, what we have is two different ways of looking at the same thing. You probably prefer to look at the bottom one. The bottom one is showing you which wires have connectivity and what kind of connectivity if they do have it. What I've concluded from this is I don't have an answer to why this doesn't work when I plug it back into the Ninja. But what I have concluded is continuity testing does not or cannot be done through diodes. And I didn't know this. I haven't actually Googled that to find out, it's like, oh, of course, you idiot, you should have known that. However, I think I've proven that continuity testing doesn't work through diodes, but the functioning of those wires is correct. So they are connected. I know that from the very first part of this video, where you see me actually activating a headlight using those two power connections. I'm able to trigger this gate that you see here between the black and the white wire, which closes the contact on red and blue, and my headlight comes on. So I know that the relay is working. I know that it's functioning in the manner that it should from 1 and from 2. What I am uncertain of is why when I plug it back into the motorcycle it doesn't work. Now there are two vague ideas I'm suspicious about. Maybe I have the black and the white wire reversed. Maybe there's a direction that this has to go when it comes to the pins. No, because the relay itself doesn't care which direction you trigger that gate, I'm pretty sure. The relay doesn't have the diodes. Okay, so I'm kind of throwing out that idea. Why might this not work when I plug it back into the Ninja? And I think what I have to do is find out why, why I might not be getting power on 2 or 1. I should be getting power on 1 or 2. And either one of those should turn the headlights on. And it probably means I have to put this back in the Ninja and test those wires that are coming from the Ninja and confirm that I'm getting the correct voltage coming through 1 and 2 to close the contact and make the headlights come on. And if that is happening, then I next have to say, okay, maybe pin number 3 there's a wiring problem between there and the headlight system. It's not a fuse, because I've already checked the fuse box on this. It's a perfectly working fuse. I did a continuity test on the fuse, and there's no diodes in a fuse, so it worked. Yeah, guys, I don't know. I'm posting this video to show you how far I got. I hope I'm posting it mostly out of appreciation for Clive, who did this excellent autopsy and gave me the inspiration to take it further and go this direction without having muddled myself into the quagmire. If I had taken this thing further apart instead of doing what I'm doing, I know I would have ended up into a soldering job that is above my skill level and certainly above my equipment level. And this allowed me to take the shortcut. I just got to find out the one thing I'm doing wrong to make this work. Anyways, if you got this far, thanks for your patience. I'd appreciate a like. I want to know that I actually helped someone with this. I know there won't be a huge number of people in the world that would stay interested in this video. I mean, the things are very specific. You have a Kawasaki of some sort that uses this relay box. It broke, and you want it fixed. But Clive showed me there's one other person out there in the same situation as me. Maybe we can find more. Good luck, guys. I'll post when I have the solution.